Hi everybody, just a quick video today to look at a special tool that we have available to us in Civil 3D that will help us compute the various values that represent a curve within Civil 3D. So where I would use this primarily would be as if I had like a paper document, something that showed information about a curve. Maybe I had the radius and I had a chord length, but I didn't have the arc length. So using those values, I'd like to take and calculate what the arc length is. Maybe I'd have information about the tangent or the delta angle or the included angle, things like that. And I have that information. I have partial information about the curve, and I'd like to compute other values just to determine, some numbers may not look right. Was it entered incorrectly in the paper document? Just a way of confirming, other information about the arc. So typically, the arc is defined or represented by a graphic that I've got shown here, this diagram. We can see, the radius, the delta angle, curve, external, secant. This is usually something you would find in the front or the back of a standard field book, and then it would be paired up with the different calculations that you could manually compute based on the values that you have, the knowns. The unknowns are the values that you would require. So fortunately for us, we don't have to do all the math. If we have some of the values, we can use the calculator within Civil 3D to determine the values that we don't have. So let me show you how this would work. I'm going to back up for a little bit here on the screen. We'll pan this over to the side. And the tool that we're going to use is the CurveCalculator. I'm going to get it by grabbing the curve area under Draw on the Home tab. And then we'll come down and we'll select CurveCalculator to launch the calculator itself. You'll see on the bottom the actual command is CurveCalculator, so we could get it by typing that in at the command line. If I bring up the CurveCalculator, the way that it works, we'll just answer some questions. We'll type in some knowns, and from those knowns, it will automatically determine for us the unknowns. Now, using the calculator is extremely easy, but it's not necessarily 100% intuitive of exactly what it's looking for. So let me show you how this works. The first thing, we'll tell it the degree of curve definition, arc or chord, and that's depends on how we want our unknowns computed. The easiest way to look at it is from an arc definition. That's more the way that they would compute arcs based on a roadway, and then chord is more the way that they would compute them in using rail. So in our case, we'll make the assumption that this is going to be more for a road definition for our arc. The next thing is we need to know one of two things. One of two things has to be known for this calculator to work. We have to know the delta angle, or we have to know the radius. We need one of those two things, and then we can compute the rest just by typing in a couple of unknowns. All right, but one of those two has to be known for the calculator to work. So let's say that maybe I know the radius is 250 feet, but I'd like to compute based off of a chord length that I was given, say it's 99.33. I'd like to compute what the actual arc length is, or the external secant, or the degree of curve, whatever the case may be. So if I know the radius, and this is the interesting thing about the tool, you'll notice that I can lock for my fixed property delta angle or radius. So what I'm going to do is if I'm going to enter a radius value, if I set radius here, you see radius is grayed out, so it's locked onto 0. All right, I don't want to do that. So if a radius is a known, I'm going to set it to delta angle. Then I'll set my radius. In this case, we'll say it's set to 250 feet. We'll hit enter. That puts in my radius. Then what I'm going to do is I'm going to click the down arrow here that I now want to lock that. So I don't want the radius to change. Now I can enter any other values that I may have. In my case, my chord length was 99.33. So then my arc length should be right around 100 feet. So we'll say 99.33. We'll hit enter, and it computes the rest of the values for me. Now, how did I know that? It's because I'm reading it off a paper sheet that I have next to me. Actually, I've got a something for those folks that have maybe used Land Desktop in the past. These are the results of CurveSolver, which is a similar tool that we had in the past. All right, so if we knew the included angle or the radius, we would put in the other values and it would compute the rest. We can see that what was computed using the other tool or the old tool in Land, I've got the same values are being computed here. All right, so that's the one trick that we have to know. If we're going to put in the if we know instead the included angle, Like maybe in this case, the included angle is 2255.06. You see the delta angle here is 22.9. It's because my angle is being represented as decimal degrees. Let's do this. I need to change my settings so that I can enter it appropriately with the information I have. Now, rather than me converting 2255.06 to decimal degrees, let's set it to something that I can use those numbers directly. So I'm going to go to Settings. We'll go to Edit Drawing Settings, and I'm going to go to Ambient Settings, and we'll come down to Angle. And I'm going to set my angle right now, we'll say for, instead of Format Decimal, we're going to set it to decimal, we'll say DMS, which is decimal degrees, minutes, seconds. So we'll set that and say OK. That will update my tool. We'll come back to my curve here. We'll say CurveCalculator. Let's bring my other document up on the screen here. We'll say this guy. Okay, and then if we know the delta angle, the first thing we have to do, because it's locked, is I will set my radius so that's what I'm going to have fixed, and then I'm going to put my delta angle in. So looking at my delta angle, it's 2255.06. So based on the new settings that I have, 2255.06, we'll set that to 22.55.06. I'll hit enter to lock that in. Then what I'm going to do is I'll lock that by locking the delta angle, and then now if I have any of these other unknowns or any of these other values that are known, I can type it in and it'll compute the rest. So what did we have before? It was like our chord length was 99.33, so let's come down, we'll say 99.33. We'll hit enter, it computes the rest of the values, and if I bring that back up on the screen here, we can see that those numbers match what was computed with the other tool. All right, so once again, if you have a combination of knowns, or you have some knowns, you can use this tool to compute the unknowns for us. It uses the same mathematical tools that we would have computed them manually in the past. The caveat is that I need to know at least the radius or the delta angle, or what's also referred to as the included angle, to be able to compute this. One other thing that the tool does for us is if I had some geometry on the screen, maybe we'll just take and create a quick 3-point arc on the screen here. If we have some geometry, there is a button up here on the top that by selecting that, it will come up and ask us to select the arced object. And when we select it, it'll automatically populate the tool with all of the information about that arc. So if you're not working off of paper geometry trying to determine unknowns, it's also a great tool to select some geometry on the screen, in this case my arc, and then using that determine, either confirm, in this case my radius is 106.21, maybe that should be 105, maybe it should be 110. I could confirm some of these other numbers, use that as part of another computation or whatever, wherever that information might be useful. All right, so very cool tool. Like I said, a little a little unique in how I may have to enter the values. I need to know that I have to, set it for the other value that I need, put it in the radius, for example, then lock that, then put in the other values, and it works quite well, and would save us a lot of time from doing manual computations. So with that, I hope this is helpful, and I look forward to talking to you again soon. See ya.